which is email or let's say phone number and password. Keycloak, no. So Keycloak, based on that email or phone number, it will call the user microservice using the SPI, and it will get the user profile.
From where?
From the user service, because that data is stored in Cassandra, which is in Cassandra. So it will. Sorry. The new user gets added into Cassandra. Yeah.
Now it will take from, okay.
Yeah. So all Google users or users who are signing up with state portal and all that, or even the username, the email or phone number based registrations, all of that data comes and sits in Cassandra.
Oh, because next time, second time, if I through Google user, it will pick from there only.
Yeah, the profile has to be picked from Cassandra. Only question is whether you have a credential or not. Means a password or not. And Sunbird allows you to come in via Google and then go in and say, I forgot my password, and set a password for your Gmail, because then you can do both logins. You can do via Google or via entering a password as well.
So user detail will be settled for the normal login and for the Google login in the Cassandra?
Yeah, in the Cassandra.
Yes. User profile will be in.
Eventually there will be two requests from the user. One for the Keycloak token to get the trust, and then the callback which they got for the name and the detail of the user for the Google login I'm talking. Then the request for the Cassandra to add this user.
Yes, that's one request to Cassandra.
And one request to Keycloak also, no?
One request to Keycloak, which will call user org service, which will then come to Cassandra. Yes.
I have one more question. So there are two types of users that we can register with the application, right? One is the state user, the verified user.
Yes.
The other one would be the user which we generate on the platform itself. So someone asked about the user which is registered on the platform. Now,
Correct.
what about the users which are state verified users? Basically, the credentials are in state system.
Correct.
How does that work?
So what happens is, when a user goes into the state portal and says go to Diksha, the state portal will generate a token.
So it's exactly similar like Google.
Okay. So Google is a OAuth, OpenID 2 compliant protocol. The state one is a more custom protocol. We've tried to take the security aspects and build that, because building OpenID compliant target systems on the state also would be a time-taking activity. So it's a custom protocol, but conceptually similar. Okay.
So I have a question
Yeah.
on SMS part. So basically, Sunbird developed with the message 91.
Yes.
We want to integrate some NIC gateway.
Yeah.
So we need to make code changes here.
Yes. Because each provider gives you a specific interface. Yeah.
So we need to introduce new variables in common, secret.
Yes.
And we need to load
Correct.
secrets in particular.
Correct. Most of the time the variables will be the same. So with NIC, in iGot we actually use the NIC's SMS gateway, but the API will be different.
No, but like NIC, I think they mentioned like they use the PHP code. So there is a customization in Java code like that.
No. They will give you an API. You just have to call the API. Likewise, message 91 also gives you an API. Now these two APIs will not be similar. So and that is not a good attempt to kind of make them uniform as well, because every provider, if you go to Twilio, they'll give you a different API. So there is one class in Sunbird where you will have to make those changes. So there is a message 91 provider, you will have to create your own NIC provider or your Twilio provider.
Which service we need to make changes?
It is, I think, in the auth
It's in notification and
user org, and also that Sunbird auth repo may be there. That's not used now. Yeah, there'll be two repositories.
Java like I think.
Yes.
And for the Firebase, we have push notifications, I assume.
Yes.
So for all the platforms, for portal and mobile also.
Not for portal, only for Android.
Only for Android.
Yes.
Not for iOS.
For iOS, I'm not really sure.
It's not there.
Right. I haven't looked at the
Why
iOS part.
in specific
It would just be that it wasn't a priority at that time for the dev team, because it is now built by a community. So what is priority for me and will not necessarily be the priority for the community. But the system allows you to extend it. So adding a new notification capability in Firebase is just configuration, and possibly because Firebase can take care of iOS pushes as well. You don't have to worry about the APNS part.
It takes care, right?
Yeah, it takes care.
Yeah. So explicitly you are pushing the notification here, right?
Correct. You send it to Google, Google send it to APNS.
Okay.
Yeah, so that's taken care of.
So this is still something to achieve.
Correct, correct. And that will be a nice contribution to get back as well. You know, like at least maybe a readme on how you went about doing it, right?
But you
That
also
will
need
be,
to think about what's the user base. You know, when you're talking about iOS 8 Diksha, do you
Yeah.
actually have a user base that actually warrants this kind of effort? that
Correct.
you put in? Because your user base for Diksha will be primarily an Android user base.
yeah,
But for future use, we have to think about iOS. That's
Yes.
Absolutely.
Yes.
no limit for it.
Correct,
These
correct.
considerations will have to go up.
Yes.
That's what you'll have to think about.
Okay.
Like experiment, like we can see, like how many, like, you know, over here, so by, so,
Yeah, absolutely. Exactly in this room, right?
yeah.
Yeah.
So for Keycloak is used for authentications, right?
Yeah.
So we can write our code for the authentication and save the cost of, the deployments of Keycloak. So why we not do that?
Who will take care of the best practices? For example, Keycloak, when it saves your credential, there is the number of times it actually hashes your password.
You want to just go back to the previous screen?
Oh,
Just keep that and-
yeah, sorry. So there are some best practices that Keycloak takes care of. Okay, one is you want to auto lock out a user when somebody is trying, let's say, 10 passwords, right? And unsuccessful attempts. You want to be able to store the credential following the industry best practices. So when we started designing Sunbird, the industry best practice was you do 20,000 hashes of the password, 20,000 times. Now we could have set it to 1 and be okay with it. But then there are rainbow tables and there are ways to, if somebody ever gets hold of that DB, there are ways to reverse engineer. So there are certain best practices which you will end up not spending cost on running Keycloak as a service, but spending time developing something like Keycloak as a service. So most of the DPGs, most of the DPIs, you will see that are now going to rely on Keycloak, because Keycloak, the community, Keycloak community is very vibrant, and they incorporate all the best practices. No amount of engineering, team can build a custom solution and take it to that, because then you will end up building a Keycloak.
And most of the cloud products are typically in some clouds are based on Keycloak only.
Yes.
So the base is Keycloak.
Yeah.
For example, Red Hat SSO. Red Hat SSO is nothing but a layer on top of Keycloak
Yeah,
only.
yeah.
And it's a very famous product as well.
Yeah, and I honestly, in the open source world, I have not heard of any other significant competitor to Keycloak. So if you attempt building that, you will miss the best practices, you will come under attacks, and it would be a challenge.
Yeah, so see, like there is, like, actually one more service we are using in Smart City. It's called the Key Rock.
Okay,
And so that's also open source.
right, and that's popular.
Yeah.
Okay.
But the concept is same, like
Yeah, you will still have to run another service. I think what he was trying to see is, can he avoid running the VMs with Keycloak?
Right. Main point is that.
But I'm saying you will end up spending more developing the code. So and still not accommodate all the best practices.
Security complexity is abstracted by Keycloak.
Yeah.
Otherwise, there's a lot of things
Yeah.
we need to do.
Correct, correct.
And even as an engineering architecture practice, if something is already available,
Yeah,
leverage that.
leverage. Yeah,
Yeah, you don't have to reinvent the wheel every time.
yeah.
So what do we do in progress?
Postgres. So the credentials I said by Keycloak, it stores all its metadata and the credentials in Postgre. Likewise, Kong also stores data in Postgre.
So I have a long awaiting question because there was a deep discussion on
Yeah.
the e-clock.
Yeah.
So the Flink is doing what?
So Flink, we have an async notification service. So if you want to send like bulk emails and all that, there is an async service that writes events into Kafka, and there's a notification service which will send the notifications out.
No, I'm asking the Flink with respect to the, so like
This block, yeah. So the notifications. So notifications are handled by this particular building block.
the audit event, the telemetry.
Yeah, audit events are also there. Yeah.
And what is the retention period in the Kafka?
It depends on your confidence. Honestly, I would say anything like 7 days is the default.
default. Yeah, it's by
Is the by default.
Yes.
Now, if you are getting 1.5 billion telemetry events, 7 days is a very costly thing.
Right, I agree.
So you have to reduce it to 2 days. But you have to be sure that you're confident of processing the data in 2 days. Otherwise, you lose
Based
data.
on the use case and the
It's on the comfort level of the team. So you initially start with maybe 7 days, then you bring it down to 3 days. Your processes are all well oiled. Then you reduce it to a day, 2 days, right?
What do you use for the retention? Like what is the value? For
So we have other clusters where we are running with ours as well.
okay.
But
Okay,
ours, okay? I mean, I'm talking about places like Ola, because the number of events coming in is too huge,
Yeah.
right?
So when we are discussing this Kafka,
Yeah.
so essentially the Kafka version which we are using is Zookeeper.
Yeah.
Then there's a Kafka 3 which is based on K-Raft and
Yeah,
it's not
yeah,
using
yeah,
it.
yeah.
So have you upgraded that in any version? Or
No, not yet, not yet. Yeah. But honestly, the Kafka interface would remain the same. It's only how you run Kafka, the Ansible roles and all that which would have to change. The Kafka will remain compatible.
compatible?
Yeah,
No,
yeah.
I was asking in the sense is most of the time we face challenges is sometimes Zookeeper goes down and we don't know why it went down, maybe some issues, etc.
Okay.
And then the Kafka thing doesn't work out. Like we need to go
Yeah.
and see that Zookeeper is
Yeah.
out.
Honestly, in my experience, I have personally been using Kafka for maybe 6-7 years. Never once we have faced a Zookeeper challenge. Never
We are
once.
facing frequently.
Okay. So are you running Zookeeper in a cluster?
Yeah, correct.
Yeah,
That is a.
we are running in a cluster.
Okay. So I think you should look at the configuration. Maybe there is some missing thing there, because honestly, I get worried when I hear about Zookeeper going down, because if Zookeeper goes down, it's a big problem. And I personally have never come across that problem. So if you,
Zookeeper will never go down,
yeah,
because if you run in a cluster, it will automatically check
yes,
the next process
yes,
by
yes, yes.
So most of the configurations what I have in some of the configurations what I have seen is they have just mentioned one Zookeeper server, and then what's happening is it goes down, and actually it shouldn't go down. I don't know what is the reason there. But then when we investigate now, we find that Zookeeper is down. We bring it up and then start working. So I think it's rather configuration part.
Yeah, it must be something to do with the configuration. Yeah.
So if I want to create a 3-node cluster,
Database will be the loss. What is that for database?
Sorry?
databases.
No, that's just the classification. What are these layers? Yeah, yeah. So these are the databases used in this module. Yeah.
Create a 3-node cluster of Kafka. So I have to create a Zookeeper cluster as a 3-node.
Yes. No, so even if your Kafka is like a 10-node Kafka, your Zookeeper can still be 3-node.
3-node. Okay.
Yeah.
That is
Yeah. Each of them 3 nodes. Yeah, yeah. It's independent.
Zookeeper just managing.
Yeah.
At a time only one will work as a leader, other will be work as a watcher.
Right.
So every time, whenever there is leader will assign which broker we need to communicate and which partition we will be working on.
Yeah. Okay. So I think I'll be, in the interest of time, I'll rush through a bit of these, because in terms of the databases, we have touched upon most of the databases, the why we chose the databases, what are the advantages, all that. Tracking and credentials again relies heavily on Cassandra, and there are Flink jobs which take care of aggregating the values and also certificate issuance. That's part of the
Assessment aggregator and
activity aggregator, assessment aggregator. Yes, yes.
Aggregator is also there.
Batch sync, huh? Yeah. So I am operating more at an architecture layer. I might not know each of the individual jobs that are there in the system right now, but yeah, I mean, these are things that you should probably touch upon in the breakout sessions.
Small question I have. Like, did you have anything that like any vertical?
Out of support, and Samsa was not compatible with Kubernetes. So when we started Sunbird, we didn't start on Kubernetes. We were on Docker Swarm, and we were using VMs for Samsa jobs. But when we moved to Kubernetes, we made a conscious decision that Keycloak probably is probably the only one which is a service but hasn't moved into Kubernetes. But otherwise, all the services, all the CPU intensive processing layer, we wanted to be on Kubernetes. And Samsa, we tried reaching out on the forums and all that, but there's no way there. I mean, support for Kubernetes exists, but it's like very little documentation. So we decided to switch to Flink. And that's a very good decision, because earlier we used to have some scaling challenges with Samsa. I'm sure it would have been like, a struggle between us understanding Samsa better.
Spark streaming also, no?
Spark streaming we had evaluated. So when we wanted to move away from Samsa, we evaluated Spark structured streaming and Flink. And Flink was a clear winner.
Not an actual real.
It's micro batching.
It's
Yes.
a very
Correct.
micro batch.
Yeah, so like you cannot compare
Yeah.
like Flink with the
So latencies are much higher, than that.
you can compare Flink, Storm and this Samsa, right? So
Yeah.
We couldn't have run Vista at the scale we ran in 2020 without Flink.
Yeah.
I think that was the year when we migrated from Samsung to
Correct.
Flink. The observability, the ability to predict the volumes that will come in terms of running issue with those credentials.
we had massive credentials that were issued on a day-to-day basis, right?
Yeah.
We were able to scale up, scale down. If it is down, people, infra, knock teams were able to proactively take those, action items and all. Flink helped us.
Yeah.
And even that process in the batch mode, like de-stream, windowing and all.
Yeah.
So Spark has certain limitations over there.
Yeah.
Where it's kind of native stream.
Correct. Yeah. So this is native streaming. That is native batch.
Yeah.
So
That's the difference.
yeah. Okay, I plan to skip collaboration. This is basically going to be covered in the UCI sessions as well. Okay, want to spend some time on the data platform. Now, so there was a statement I think you made, right, like where you said that there are 2 Druid clusters and also I want to touch upon some of that here. So when you want observability, when you want an event-driven architecture, you want a solid messaging pipeline. So we have chosen Kafka as our messaging pipeline, right? And then you create a spec saying that all events should adhere to the spec. So we created the telemetry spec, and we have our our consumer touch points, right? The mobile app, the web portal, the desktop app, all of them generate telemetry. Our APIs also generate telemetry. All of these events come into Kafka. And then you have the streaming pipelines, which actually take care of 3 broad things, right? I mean, it's actually not 3 jobs, it's slightly more than that, but 3 broad things. One is dedupe. We've seen that 0.1% of events get resent by the client app. What does that mean? We have exposed an API for them to send telemetry. What will happen is the client makes a call, submits the telemetry packet, but before they can get a 200 OK response from the service, they lose connectivity or somebody takes it in the background or kills the app. You run into multiple problems. Okay? So you need the ability to dedupe events, otherwise you'll be double counting. Okay? So that's dedupe. How do we do dedupe? Dedupe is every packet. So telemetry comes in as batches. You can configure it for your applications. Typically 50 is a good size, 200 is a stretch because sometimes your user may abandon the app before they get to 200 events and you will not know what they did, right? So you would create batches of these events and you can put a UUID in that batch. And the dedupe layer is going to check if that UUID exists in a Redis. So this is one place where we use Redis heavily. If it exists, it means it's a duplicate. You can trash that event. Otherwise, you process it and you add the key into Redis so that the next duplicate arriving with the same packet will be caught. So that's dedupe. After dedupe, you have to validate that the events are fine. Now in production, you do not expect validation errors. Validation is actually meant to be caught during your dev and QA phase, because that implies that there is some new developer possibly in your team who is sending events and not adhering to the spec that you have created. So that's the validate part. And then we have the enrich. Now enrich is important because this telemetry data, especially the data at this stage, right, or the data at this stage which is unique, it is going to be saved in blob storage for a long time. When it is being saved there, you don't want to be storing personally identifiable information, PII information. So that should get attached in your enrich layer, and then you can have that data. And there also, don't put things like email addresses and phone numbers and all that, but you can go to the extent of saying that this user is from this region of India maybe. That's considered non-PII. And there's a funny incident when we were explaining this to somebody from Norway, and he was like saying in Norway the population is so less that if you say this is a user from this region and in 9th standard you can possibly identify the user as well. But in India at least it is not a problem. So we can be as elaborate as that, right? So there is this pipeline, and at the end of this pipeline, all this data goes into your raw Druid cluster. Now the raw Druid cluster is for ad hoc analysis and reporting.
One second, can you explain validate and enrich? I don't understand.
Yeah, so validate is just ensuring that all the events that you're getting are adhering to the spec. Okay. Because you have defined the spec, right? Your spec says who did what in what context. So you want to be ensure the JSON structure. Yeah, it's a JSON schema validation. Okay. And enrich is, let's say in the case of let's say there is a content ID coming in telemetry. Okay. And you maybe want to add what grade that is for, or what subject that is teaching. If you want to enrich, I'm not saying you should. Yeah. So if you want to add additional data, because you don't want the client to be sending all this data, right? So all that happens in the enrich, and then all of it gets into your Druid cluster. Yeah.
So, but it goes to Kafka first, right?
Yeah, everything goes to Kafka. So each of these stages push it.
Some storage as well.
Not everything. So what happens is there are certain checkpoint topics. From those checkpoint topics, we use Pinterest C-Core to back up the data into cloud storage.
They have to push the data into
Cloud storage. Yes. Yeah. Sorry, that's the question. Okay. Yeah. So that is important because Kafka, you have your retention. So you lose the data after some period of time, and you may also want to do some ad hoc analysis with, let's say, a Spark engine. So how do you do it? You need a backup of that data, right? So C-Core handles that backup.
I have one more question.
Yeah.
So this telemetry, these events, they are how, I mean, what is the coarsity of the events? I mean, can we group some events together, or it's at a very what do you say, like the interactive events, like for example, a user clicked a button.
Yeah.
Do we say that?
Yes. So we broad thinking. There are 16 or 17 types of events, but broad thinking is every interaction that you do and every impression that you see, right? Apart from the starts and the stops. These are the 4 main event types, right? Now,
Everything is captured in Druid.
yes, everything comes into Druid, and because the volume is huge, because 1.5 billion events a day, I mean, if you keep it for a month, you have like 50 billion events, right? So because the size is huge, and you don't want to afford, I mean, like run a massive cluster, you will say that the retention is a bit limited. And that is the reason why the summarizers are important. Now, when you get these discrete stream of events, a simple question like how much time did user A spend on the platform cannot be answered from these events. The amount of compute you need to run this in a query format by assimilating all events and looking at start and end time is humongous. So you want to be predetermining that or pre-computing that and ingesting that into Druid as well. That is exactly what our summarizers do, right?
Summarizers, there are Flink jobs also for summarizer, data summarization.
So summarizers are Spark jobs.
I had seen some summarization Flink jobs also.
That will be for a different use case, not in the Obsrv stack. Yeah, no.
So again, you are connecting to Kafka and all, or directly you can connect?
No.
from-
So the summarizers don't read from Kafka.
so
They read from the Pinterest C-Core backups.
like all batch jobs which are running night.
Yeah, no, that
Those things, those are that's data summarizer,
so
right?
so there are some summarizers which query data from Druid, but the summarizer that I was speaking about is a special summarizer called the workflow summarizer, which actually says that this user came, spent 10 minutes, visited these pages, interacted with these buttons, played 5 content, that kind of summary. That is done by a special summarizer which looks at the Kafka data which has been backed up into cloud storage and computes it from that data. So if your Kafka storage from using C-Core is unsuccessful, then your first summarizer of the day will fail. Okay. There are also other data products.
Why can't it directly interact from Druid?
No,
Any
because it has to collect all that data and sort it by user ID and device ID and then do all that. So the amount of data you will be pulling from Druid. See, Druid is a very specialized data source. It is good for looking at a smaller section of data. If you try to fetch all data from Druid for a particular day, that's be inefficient.
So you get it through Kafka.
Yeah. Not Kafka. We fetch it. So the Kafka data gets backed up into cloud storage, and the data product will pull it from cloud storage, process it, and then push those summary events into Kafka, and then that goes into a Druid cluster.
So because of that reason, that night job which the job I'm running for data extraction, so because of that reason it takes time.
No, actually
It doesn't take time because of this process.
Yeah, so if we were reading from Druid, it would actually take more time.
But
Because
through this the other process which
yeah, because it is reading from cloud storage, even if you have a billion plus events, it will do it in like less than half an hour. Yeah.
Hey, no, I have one question.
But
Just
only
one-
the problem is, Manoj can suggest, because what happens is consistency of data. In Druid and Kafka and all, when we are generating report, sometimes there is no consistency of data. So what could
So
be that reason?
if you ensure that your lags are under control, which should be the primary responsibility of the NOC team, you will not face any latency challenges because they are time bound. If you ensure that the data that you have got till midnight is ingested into your Druid clusters and it is ingested into the cloud storage via CCore. If you are able to ensure that, all your next day's jobs should be fine.
In fact, that's one of the key responsibilities of the NOC team, just to
Yeah.
ensure that they watch whether the lags are
Yeah.
cleaned up.
Okay, and so the idea of these, sorry.
I have one use case, and
Yeah.
I don't know whether how much it is enough to take sure.
Yeah,
Because you have written a Lambda architecture, and I have this real-time pipeline.
yeah.
So I have a data coming, and then when we do a dedupe and we do
Yeah.
a validation, a developer validation.
Yeah.
Right. So it's not a production validation. Then we go to enrich. Then it goes to storage. It goes to summarization. Summarization.
Yeah.
Will go to a Druid in dimensional model.
Correct,
OLQ,
correct,
all this
correct,
stuff.
correct.
That's all done. Suppose in this data while doing this flowing, and I want to do some kind of a like ML algorithm I want to run. Based on that, I want to send a notification. Hey, look, this happened, that happened. You just take case of credit card, bank credit
Yeah,
card
yeah.
data is coming here.
Yeah.
And I want to do real time alert.
Yeah,
And
yeah.
at the same time, I'll go
Yeah.
and do a summarization.
Flink is your ideal candidate to do that.
Okay.
Flink supports embedding ML models. So if you want to look at, because all the data goes through Flink, if you want to pass that through a model and do decision making, so in a
Which part I do that? Is enrich part?
no, you will have a new job.
Okay.
You will not see. You want to ensure that enriched events are getting out of your processing layer in like a 2-3 second latency, not more than that. Your ML thing can be maybe 10 seconds latency as well. So you will have another job which is specifically looking at all that. Yeah.
And that we can do through the Druid as well, because Druid have all the raw data.
Yeah.
And for the pattern or any kind of recommendation or risk analysis, we need like real-time data as well as the older batch data.
Yeah.
So on which we will do a set of training and then test and then evaluate, and then probably we will identify whether this is a risk factor or not.
Right.
And then probably, so in that case, Druid.
No, Druid is, you should just look at Druid as your processing, as your data store, not as your processing engine.
No, from Druid we can.
You can use Druid as a data store for all your computations. But these kind of use cases that you're speaking about are best done in Flink. Flink is actually meant for those kind of use cases.
And my second part is, do you have any concept of a master data here?
If you look at content model in knowledge, that is master data. If you look at list of organizations in Lern, that is master data. If you look at list of users, that's master data.
So suppose like you're saying you use this thing for like Ola.
Yes.
Right? So I'll take this platform for some other
Yeah,
use case.
yeah.
And where I want to handle master data.
Yeah.
So like which portion of the database should I consider my master data?
So this is typically you will not have master data in a Druid like setup, you will have it in a warehouse.
I think it's
See, Druid I understand, it's a
Yeah.
pure OLAP.
Yeah, correct.
It's written-
Yes,
it's
yes,
OLAP.
yes.
So it's just for a like summarized analysis
Yeah.
and all those things. Probably they record to Power BI, Superset,
Yeah.
Tableau, whatever.
Yeah,
And this you told that you can do a real time over here on things, that notification, whatever.
right.
So while doing this, I want to refer my like master set of data, right? As an organization, I want to keep my master data.
Yes.
And all those kind of stuff.
Yeah.
Where do I keep in this architecture?
So you can choose to put it in a Cassandra like DB, because if it is lookups that you need, or in our case, I'll give you an example. In the enrich layer, we wanted the master data of all users, not all master data, but essentially which state and maybe city they belong to.
Yeah, see, correct. Because see that layer enrich you
Yeah.
right? Because I will see this and I'll try to categorize them.
Yeah.
So those categories should not be hard coded.
Correct.
So because you define somewhere in master, because you
Yeah.
define your organization.
Yeah.
So that where do I define?
So there are two places. One, you can use a Redis from your enrich layer, or the Flink itself comes with a RocksDB instance where you can actually store data. One of these two places. If you want to avoid a hop, RocksDB. If you're okay with a hop which gives you a 2 millisecond latency, go with Redis. Right? And going back to the reason why raw data is kept for a shorter duration is primarily just cost. Druid can scale to hundreds of machines as well, but is it worth running a Druid cluster with 100 machines, and is somebody going to query that data? So you would typically say that maybe 1 month of raw is, or 2 months you said, right, is currently 3 months of raw is what you will keep in the raw cluster, and summaries are going to be probably 1/100th the size of raw.
Even
So
the SQL job that is running, that holds the data from the beginning. Like, but we have a middleware. Middleware in the tool that actually loads the data into different segments and creates the data sources.
Correct.
So, I mean, anytime we can leverage, we can change the like middleware where it.
Yeah, it's not middleware, it's middle manager. Yes,
Sorry,
yes,
middle manager.
yeah.
So there we can customize those parameters.
Correct.
And then
Yeah, when you submit a spec, you can indicate if you want to reduce retention, if you want to increase retention, all that is configurable in Druid. Yes.
So this superset is being utilized now?
Yes,
It
yes.
is, there?
I mean, Sunbird allows, I don't know specifically about Diksha.
So I'll tell you something about superset because we keep working with superset with Power BI.
For visualization, we are
Right.
Yeah.
It's way behind all the tools available.
It's kind
Yeah.
of like
Yeah, that's because it is free.
Yeah, because I
How much is a Power BI license for 10, 20 people? That's the difference.
But even they can take a $10. Like people will pay, I guess. But
Yeah,
it's way
the-
behind.
Yeah, so there are providers like Imply which give you better dashboards. So they say you don't
We
even.
do when build the architecture, we give this option, but no, when
Yeah.
we also know it's not going to work,
Yeah,
they
yeah.
also know it's not going to
Yeah,
work.
yeah,
But
yeah.
again, the user base for the entire superset is very limited. Right? You know,
Yeah.
we very clearly know what are the kind of queries that they need. So, I mean, from their perspective, it works.
Yeah.
But like I said, this is completely fun. You can change it to anything else you want. You know, it doesn't have to be superset.
Yeah.
The tool is like you can put it, somebody pays it, they can take it, right?
Yeah. So I think we have touched upon most of the building blocks. The next bunch of slides I want.
I have one question.
Okay, okay, on the data.
So,
Yes.
So
Yeah.
the filling job is transfer data to Kafka and the data lake, the cloud storage. So what cloud storage we use here?
Yeah, so there was a question about cloud storage specifically earlier as well. So I would skip a bunch of slides due to paucity of time and see the next set of slides. Maybe I'll just run through. Bear with me. I'll tell you how we have abstracted it out. So tech choices for scale. There's benchmarking we have done, and this is a public repo as well, right? This proves that the system can scale to even 75,000 TPS, right? The scripts are there. And be aware that, you know, when we were actually doing load testing to simulate 75,000 TPS, your JMeter cluster itself has to be some 25 servers to generate that kind of load. So that was all done as part of Sunbird. It is, you know, the scripts, the results, the architecture, the infra design, all of that is there in the repo.
And I think it becomes important. I mean, you know,
Yeah.
probably others in Amit or the other architects over here, when you're actually going to be talking about NISTA 4.0, other things, you should anticipate this kind of a load.
Yeah.
Okay, if there's going to be some active program setting that's going to be happening by NCRT,
Yeah.
these are practical loads that will hit you. So 25,000, 30,000 TPS will be the norm.
Yeah. So how to be cloud agnostic? This is something I wanted to touch upon. So the first thing is we ensured that, you know, we rely on Kubernetes as the operating platform, and Kubernetes is agnostic of cloud. That's one, right? The second part was not everything runs on Kubernetes. You will also need something to run on VMs. So what we did is we actually said that you can have a VM on any cloud provider, but as long as you have an operating system which is Ubuntu 18 or 20, we have open source Ansible scripts to set up whether it's a Keycloak, whether it's a Cassandra or a Postgre or all of that, that gets taken care of by Ansible. So these are two important decisions we took to ensure that we are cloud agnostic. Because a VM is a VM in any cloud, right? The third thing is when the application had to rely on cloud storage. This is where, you know, we also had to iterate a couple of times to get it right. Now, I spoke about how we are running Sunbird instances on GCP, AWS, NIC Cloud, Azure, and OCI now, right? So for that, what we ensured is that we have Spark jobs which want to write reports to cloud storage. We have your microservices which want to write to cloud storage, right? We have ensured that there is an SDK that each of them will use. So Sunbird has a cloud storage SDK. The cloud storage SDK is a wrapper over JClouds, which is a very popular open source SDK that is available for being multi-cloud. We created the wrapper because we needed certain interfaces for our use cases, and JCloud was a very generic interface. So it is mostly a interface convergence that we are doing with this wrapper, but underlying it's all JClouds. So we ensure that at every point where we want to read or write from cloud storage, we go through this SDK. And the moment you do this, then if you want to add, let's say, Alibaba Cloud, most probably Alibaba Cloud is maybe S3 friendly, but let's say a new cloud which has its own via protocols for cloud storage, you just have to make a change here. And this SDK is compatible with AWS, Azure, GCP, OCI now, and OpenStack. OpenStack is what runs all your on-prem clouds. So NIC runs OpenStack. I'm pretty sure any organization, enterprise which has their data center also runs OpenStack. So pretty much all the cloud providers are taken care of with this abstraction.
So for NIC also you did same methodology?
Yeah, it's the same. Sunbird is part of the iGot solution.
Yeah.
So entire thing is deployed on NIC cloud. So that's the agnostic part. I hope this has answered your.
Just one more question. So this SDK only has this cloud storage wrappers built in, or it has other functionalities or use cases as well?
No, it has a certain interface to read and write data to cloud storage.
That's it.
That's it. It's a cloud storage SDK. No other cloud services are abstracted there. Okay.
It's used for putting file and getting file.
Yes. All interactions with blob storage if it is Azure, or S3 if it is AWS, all of that gets routed through this SDK. Okay. So these are the bits I wanted to touch upon. I think we are well over time, so maybe I'll try to wrap in 5 minutes. Do I have 5 minutes? Yeah. Okay. Yeah. So
One thing is in the cloud storage, you are seeing the AWS S3.
Yeah.
Right? So instead of that, we can use the HDFS as well to make it, compatible with all the systems.
but running HDFS is even more costly than cloud storage. See, cloud storage, they give you 9 nines of durability and consistency. To get that on HDFS, you will be investing 100 node clusters, which is your entire infra kind of, right? So I wouldn't advise you thinking of, so this is one place where you actually want to use the native offering, but you want to put a layer in your code so that you can switch when you want to. Okay?
Then telemetry data, that telemetry data is nothing but when user is interacting with the website. That is the telemetry data, right?
That is one.
Like
The APIs also generate audit events. That's also considered telemetry. They are also to the
Google
spec.
Analytics as well for the same purpose.
You can use Google Analytics. The only challenge with Google Analytics is Google is taking more data than what you're imagining. So, if you're okay with that. So that's one problem. But even if you discount that problem, when we started building Sunbird, we wanted to be offline friendly. We wanted it to be offline first and online next. I mean, and then Geo came about and disrupted and connected the end. I mean, imagine India in 2017, you would pretty much be certain that you will not have internet connectivity if you go to a remote place. Right? Versus now, Geo has really changed and other telecom providers have, changed the game now. So now it is online. That's why Google Analytics is a viable if you're okay with the data being shared. But otherwise, Google Analytics just does not work offline. They drop the events. They don't keep caching. The telemetry SDK that we have in our mobile app, you use your mobile app for a year without internet because you can sideload the e-cars and all that. And then if you sync, all that data will still go to the server. So we don't drop a single event.
Okay. So the internet.
Yeah. So it's offline first thinking. Okay. So we've covered significant parts of the architecture. I've tried to give you a view of why we designed certain things the way we designed. You can build all these, but if your infra is not designed and secured well, none of it matters, right? So this is the blueprint that we typically use and recommend all Sunbird adopters to use. So in your entire infra, you will have public IP addresses for your VPN server and for your load balancer. Everything else should only have private IP addresses. That's the first and foremost rule. The only way for anybody to touch the system is either come as user traffic hitting your load balancer, in which case they are accessing your APIs, or not just APIs, your HTTP assets, even portals and all that. Anybody who has to really SSH has to log into VPN and only then be able to SSH. Okay, so if you take care of this much, your perimeter security, and you put an API gateway, your perimeter security is taken care of. Things like OPA should be your next evolution, which is why you will see that Sunbird also adopted OPA. We adopted OPA probably in 2020 or something, right? When we realized that perimeter was just not enough, we needed more, right? So, and this is how, we advise that everybody set up their environments. You should have a admin VNet or a VPC or whatever is the cloud you're in, and you should first SSH to a Bastion host in admin VNet and then SSH to the environment specific VNets. If you expose your Bastion host directly from the VPN, then you will not be in control over which users have access to which environments. right? So this is something on the environment best practices, and this is an important slide. I mean, what happens to a web request once it comes into Sunbird? It hits a reverse proxy, which does the routing. So typically routing would be what has to go to Keycloak will get routed to Keycloak, what has to be routed to your portal will be routed to the portal, and everything else is an API. So it will get routed to Kong.
This is an ingress controller, right?
It is not an currently I don't know in Diksha, but in Sunbird it is not an ingress controller. We actually run it as a daemon set. Because ingress controllers, they have some limitations. If you want to, let's say, block traffic from only certain countries, you want to put GeoIPs, those capabilities are not there in ingress controllers, at least as of my reading, maybe a year, 2 years back. Okay, so we are running Nginx as a daemon set and a node port service, and the load balancer just routes traffic to those Nginx servers. And when there is an API call, Nginx calls Kong, and Kong will do the authentication checks, the perimeter authentication checks, and then forward it to the different microservices. And those metrics on the right are important. We actually, you would have all seen the dashboards, right? The nice Grafana dashboards that we have, API manager metrics and all that. That's all possible because we use StatsD and a bunch of plugins. Sorry? Oh, you haven't seen it? You should see it actually, because that can kind of give you a view of what exactly is happening in your system. I'm sure a lot of people in this side have seen. I got surprises there. Yeah. So you should see those dashboards because we have spent significant effort trying to build those dashboards, metering those data sources, and ensuring that the data is visualizable for anybody who installs Sunbird, right? So you get to see what's real time. You get to see how many transactions per second, which APIs, how many calls, response times, all that kind of stuff. Request response sizes. So if you see that somebody is like downloading big files, then you have to be.
I had one question here. So coming to the Kong part,
Yeah.
what I have seen is we have used the open source
Yes.
version of the Kong.
Yes.
And if we go into enterprise version, Kong itself has a dashboard. So
Yeah.
currently in our implementations, nowhere we are supporting, from the Sunbird point of view, we are supporting the Kong dashboards, etc.
No. But Kong dashboards is just another port opening in your Kubernetes YAMLs or help charts. But integrating that data with Grafana is important because if you have like 5 different portals where you have to monitor versus one Grafana where you log in and you are able to see everything, that's a huge difference. So even if Kong has nice dashboards, I would still say that relying on a second source of a stream of metrics is also a good idea.
So we have
And
used
what is here blob storage like from the
No, that is static assets. There are certain cases where, like, let's say the thumbnail images, they come via proxy. They don't go to CDN probably. So that gets routed via the Nginx to blob storage.
So Amit can tell. So we have used WAP. Okay.
WAP.
So yeah, WAP. So for then that is on top of.
No,
before WAP.
that'll be here.
Here,
Before Nginx.
Then what the use of Nginx? That's what I'm not getting.
Nginx does the routing.
Routing only.
So okay, so routing is the basic thing.
Reverse proxy, but is it a server or?
It's a server.
Server?
It's a service running in Kubernetes.
Service
Yeah.
running in
Yeah,
Kubernetes.
yeah.
Then it,
Correct. It's you can practically think of it as a layer 7 load balancer, but it does some very important things. Okay, GeoIP capabilities are embedded. We also have connection rate limiting. So if you want to say that from this IP address I only want like let's say 300 new connections every minute, you can do all that kind of stuff in there, and you will see that in the Sunbird repos as well.
The Grafana dashboard, the funny incident in 2020 when we were going those crazy numbers and all, I was in charge of running Insta from a product guy, and I'm non-tech primarily. So I knew Anandvarda and his team were doing their job, but I was so anxious, I used to ask them very frequent questions. Then they gave me the access of Grafana. I knew what jobs I need to look at. There are only 2 jobs, batch activity aggregator and the certificate job. And then the TPS that was shared there, and API errors for some of the key login, enroll, and 4-5 things. They give me, you boss, you look at it and see we are doing a good job. So that dashboard actually calmed down my anxiety levels.
No, I just want to add on to this. I mean, if you folks haven't looked at Grafana, I think this should be one of the key indicators for you. Because even when we were talking about Nista and a lot of other programs, I don't think we have reacted to a call coming from the field. We have only always reacted to call coming from the NOC team. Our NOC guys used to say, hey, listen, this API is going down. and we used to get a call from the field only 5 or 10 minutes later.
Yeah.
Okay, and so that way, please focus on getting your entire monitoring in place. And this was a key SLA that we had from the NOCSOC team. It is not just about infrastructure monitoring; it is about application monitoring also. Make sure every single API is in place and the system runs through and through. I don't know whether you've noticed we actually consciously put on the Diksha front page we said application availability. We actually had that as a measure also. You know, and until then we actually had 100% availability through and through.
So the Grafana dashboards that you're talking about, I've seen those dashboards. So it is a combination of basically the matrices which are coming from Kong, where the API calls are being made,
Yeah.
along with the matrices which are coming from the Nginx reverse proxy.
Yes.
Which is basically routing to the static.
Yeah.
It's a combination of the two.
Yeah. So the way it works. Okay. Go ahead with your question.
If I just, let's say, if I want to monitor only the API calls, because I'm assuming, let me assume that I have my content consumption being taken place from the portal, and I just want to have a look at what API calls are being made, how many, what is the matrices of those, so I can still get the Kong dashboard. I can get that information on the Kong dashboard. Yes, it will not be as comprehensive as the Grafana dashboards, because that is more, what do you call it, custom made.
Enriched.
Enriched and more custom made.
Yeah.
But the Kong would still give me a brief, bird's eye view of
Yeah.
the API calls, right?
Yeah. Yeah. And the way it works.
Basically, what we want to track, suppose 100 API hits are same API hit are coming.
Yeah.
I want to block that one. Okay. For monitoring perspective, I can see it on Kong.
Yes.
Okay. And suppose then I have to do it my whatever changes.
So you have to do changes here if you want to block certain things.
I think you also want to take Grafana, how it's a more holistic view of the entire thing
Yeah.
rather than just a component view.
Yeah. Yeah. So.
So everything we are interacting with the website or the backend services, everything is goes to the Grafana for our log.
Yes. So just because there is interest in Grafana and
Fun fact is Diksha was not opened outside of India until
2021, I think.
2021. Diksha was not open outside of India. Only when CBSE made a request to MOE, because they had schools in the Middle East and all.
Yeah.
That was when I think it was a decision taken by MOE and NCR.
Yeah, so we realized that, early days, people were talking about a lot of hackers coming from many other countries. They said, let's cut off non-India access.
But nowadays I have seen at least 2, 3, 4, 5 cases where it is being accessed by outside.
You might actually want to watch what the traffic is.
Acha.
Please,
Yeah.
I mean, these are things that we should actually start watching. And these were things we used to watch, I mean, where is this traffic coming? Why is it originating from an unknown place?
Yeah. Fun fact is, we did this in Ola, and Ola scooters are sending data from US, and Ola scooters are sold only in India. So then we figured out that there are some 200 scooters purchased by the competitors, and they've taken it to. Yeah. So watching matters. Yeah. So because there is a lot of interest on the monitoring and log aggregation, this is the last slide, I promise. Okay. So this the architecture of monitoring stack is like this. You have you have a Prometheus and an alert manager. Prometheus is a pull-based monitoring engine, which means you can configure Prometheus with scrape targets, and you can define a frequency. It will keep scraping the data from those targets. Now, on every VM, you will have something called a node exporter, which will emit node-specific metrics about that VM. Okay, like CPU usage, disk IOPS, network in, network out, all that.
Part of metric server, right? Kubernetes metric server will.
No. I'm talking about VMs.
We have node exporter.
Node exporter.
Okay.
Okay, so there is a node exporter in the VMs, which
So
gets scrapped.
application running on the VM
Yes, which gets scrapped scraped by Prometheus. Okay, and for the Kubernetes nodes also, we have a node exporter because you want to know how the Kubernetes nodes are behaving.
metric server.
Right, and then the Kubernetes metric server is giving you metrics about the pods running on Kubernetes. So in Kubernetes, you have to monitor both. How are your Kubernetes nodes doing, because they are also ultimately VMs, and how your application is doing. And FluentBit is used to capture all the logs and ingest that into Greylog, which is our logging stack, and underlying Greylog leverages Elasticsearch to store the logs. It just adds a processing capability.
Is any transformation being also done in the FluentBit configuration?
For very little. I think for Nginx, we wanted to be able to run queries like show me logs where API call response times are greater than 60 seconds. For that we have done some very minimalistic thing. Again, I would suggest that when you have the DevOps session, you should bring this up, because like I said, I mean I've
Out of the box, we don't have the application, as Amit mentioned, of tracking a request from end to end. Let's say, for example,
we actually have that. I'll come to that. Okay, we have a homegrown solution. I don't know how effectively it has kicked in. So before that, I will just touch upon one aspect of monitoring. Node exporters are just giving you CPU metrics, CPU, memory usage, disk, network, all that basic metrics, right? Sometimes you want specialized metrics. So for Kong, we use something called a statsd exporter. So Kong emits statsd data. So we capture that using a statsd exporter, and that is how your API manager dashboards are driven. Likewise, for databases like Cassandra, you want to know how much time, how are the read repairs, you want to know many things about Cassandra. So there is a Cassandra exporter that we have put. Likewise, for Kafka, you want to know some other kind of, so there are Kafka exporters. So it is an ecosystem where anything that you want to monitor, somebody else has already created an exporter for that. So all you have to do is just add that exporter and then put a scrape for that exporter in your Prometheus, and then you can visualize that in Grafana.
that exporter is supposed to be put on the VM or on the Kubernetes. I mean, I don't.
So both. So this node exporter is running as a pod in Kubernetes. But if it's on Kafka, you wouldn't put an exporter here to look at that. You will put it on the Kafka VMs.
And similarly for Cassandra, on the Cassandra.
Correct, on the Cassandra VMs, right?
So suppose in this stack, if I added 2 more subjects, let's say for some application, MongoDB.
Yeah.
So for
You will have a MongoDB exporter.
and I can
Without
add
searching on the internet, you can assume that there will be a MongoDB exporter.
and
Yes.
So that I can add
Yes. Yes. Yes.
So is this data stored somewhere for like historical analysis?
So Prometheus has a retention. Prometheus puts this on file system. You can keep backups.
So basically Prometheus used to
Time
track
series
the database or the systems basically. This is a system monitoring basically, like the VMs and the containers,
Yeah,
the database.
it's not just system, the Madhu said, right? It's not just infra, because the moment you use a statsd exporter and you start pulling things like how many API calls and all that, you are slightly,
You cannot like monitor through the Prometheus.
you can.
Why use the Grafana?
Prometheus is just pulling the data and storing it. Grafana is the visualization.
But visualization is also done through the Prometheus.
So
Prometheus
Grafana
is also
visualization.
PromQL is a very, so you should look at Grafana, because Grafana is like miles ahead. It's like the Power BI versus Superset example that he gave. So PromQL is a very, I would say I would never look at PromQL, honestly. It is only for debugging. Are you getting the data that you are expecting? But all visualizations should happen via Grafana. Okay?
So we have another like DB, influx DB,
Yeah.
Transit DB that
Yeah.
we get the exporter from the Kafka and
Yeah.
transit vessels we store the
Yeah.
information from the Kafka different topics with data.
Yeah.
So that also going into Prometheus and then to
Yes, it will be. The only, InfluxDB used to be the king of monitoring time series databases. The only challenge is clustering in InfluxDB is a enterprise feature. So that,
we have standalone VM.
yeah. So it will only work in standalone if you are on the open source version. Yeah, and obviously, alert manager. So Prometheus scrapes, collects all the data, and you have alert manager where you can put in rules. Like you can put in rules saying that if your request per second is dropping at more than 10%, alert, because somebody needs to look at why is it dropping.
And for consistently for 3 minutes.
Yeah, you can.
Then alert.
Yeah, so it has a nice descriptive DSL, so you can like play around, and you will see that there are already a lot of alerts in Sunbird.
I have maybe a related question, not exactly from this slide. Let's take a hypothetical situation where from the Sunbird stack, we have removed Prometheus. Okay, we Prometheus, or let's say Grafana. I have removed Grafana. I have deleted all the VMs that were hosting Grafana. Now, from the DevOps pipeline, can we set it up again?
Yeah.
Does it come by default?
Yes. Yes.
And there must be some jobs which we can just run and set it up again.
Yeah.
And then configure whatever.
Correct. So be aware, in Sunbird, anything that you do, so Grafana, once you log into Grafana, if you log in with admin credentials, you are allowed to create new dashboards. but those dashboards are transient, which means the next time the DevOps team runs the jobs, all those dashboards get replaced with the default dashboards in the system. So you're supposed to add it on GitHub and then deploy the job so that they're permanent.
No, I'm not talking about the configuration of Grafana.
Yeah.
I'm talking about, let's say I deleted a node.
Yeah.
I'm a new developer, and
Yeah.
by mistake I deleted, it's just a cloud
Yeah.
VM, right?
Yeah.
So I deleted
No, it's
that.
not a VM, it's running on Kubernetes as a pod.
Kubernetes,
Yeah.
okay. Let's say I
Yeah.
deleted that, or for whatever reason I removed that configuration where
Yes.
that Kubernetes pod is
Yeah.
starting. Now I can run a job from the DevOps pipeline.
Yes.
And
Recreate it, correct. And you will still see data from the past as well
Yeah.
when Grafana, because your data collection is Prometheus. Now if somebody deletes Prometheus also, then you're in trouble. But otherwise, it's just the dashboarding part. Yeah.
Okay, so like in this stack, like do you have a rules engine?
Yeah. So Alert Manager is the rules engine.
Oh, but that is very specific to Prometheus, right?
Yeah. So give me a use case that you're thinking of.
So in general, you take case of Ola, and I want to build some rule of dynamic pricing or something like that.
That will not be in the logging and monitoring stack. That will be as part of my data layer itself.
The data layer, so
Yeah.
I need to write my rules.
Yes. That is done in Flink. Any high velocity.
But, you have like an open source rules engine like
Rules, yes.
Rules is there,
Yes,
then
yes.
rules is there.
Yes.
Then you have like flowable and blah blah.
Yeah,
blah.
yeah.
So like those things can be integrated.
Yeah. So I have, in the Obsrv instance in Ola, I've actually gone ahead and put rules because we had to look for certain things.
Correct.
We are able to handle 4 or 5 billion events in a day through rules as well. So it's absolutely fine.
Okay. And you have like one more service, right?
OPA. Obsrv is actually a brand name for the entire data architecture building block. Yeah. So just like knowledge is for the content representation, taxonomy, search and all of that, Obsrv is the data stack of.
So that's what you actually used in Ola.
Yeah,
You used
yeah.
the Obsrv stack.
It's the
Obsrv
same
like
stack.
the-
Yeah.
Okay. So the data access part of it.
Yeah.
Okay, got it.
Because that's IoT, vehicle send data. So.
And so like just give me a use case of like IoT here, let's say smart city or like devices I'm bringing in, like how do we implement?
So the same data pipeline you can use.
The Flink
So,
pipeline.
because Flink is, can process like hundreds of millions of events every hour. So as long as you define a spec and then you write your processing in Flink, you can plug in any kind of data.
And also the database TSDB is like what I require.
So-
TSDB, Postgres type scale or TSDB.
No, what we have seen is
GradeDB.
So we are using Druid as our time series.
Okay.
We did not go with the Postgre timescale for the reason I mentioned earlier. Like we did not want a single master. Postgre timescale is built on Postgre. It is still a single master. You cannot have 100 million writes an hour in a single master. It will just kill you. So we wanted the horizontal scalability part. Okay.
Greylogs backend will be Elasticsearch.
Yes. And the reason we put Greylog is earlier, now Elastic supports putting pipelines and processing rules and all. Like if you see that from the same IP address you are getting like more than 100 calls every second and you want to do some alerting. Earlier you could not do that in Kibana, but you could do that in Greylog. But now Elastic themselves have brought in some of those capabilities.
Even OpenSearch, so Elastic has gone SSQL, so even in OpenSearch and Open Dashboards,
Yeah.
they have that alerting now.
Yeah,
So,
yeah. Yeah.
And Oracle supports OpenSearch.
Correct. So that came in the versions like 2-3 years ago. And okay, there was a question on tracing. That's probably the last thing I wanted to cover
That
on.
was my question also. Why
Yeah.
we haven't used any Jaeger, etc.?
So scaling Jaeger for 25,000 API calls a second, I don't know how practical it would have been. So what we have done essentially is in our Nginx, we introduce a trace identifier and that comes as a request header into all your microservices. The microservice can log that trace ID for every log that you are putting in.
And span ID also, right?
Span ID is not necessary because once you put the trace ID, if you go into Elk and then query with that trace ID, you will essentially see all the logs from all the services.
But if I want to see the calls,
That call stack you will not get. For that you have to use an eager kind of system, but then you'll have to, scalability of eager and all that is also, an infra cost as well. So for us, we just wanted to see how we wanted to trace the requests across the microservices and that we have done with the trace ID.
so I have one, so if why haven't we gone with any service meshes available? So
We evaluated service mesh, but there was no business justification. So when would you use a service mesh? You would want, let's say if you want to look at headers and route traffic accordingly.
traffic mirroring is one use case.
Yeah, that
virtual TLS is one use case.
we have done traffic mirroring using Nginx.
Okay.
So we in Nginx we have the capability to mirror traffic. So we actually tried Istio,
Okay.
and Istio would use 10% more CPU on the Kubernetes cluster.
Yeah, agreed.
So the cost was going to be high, and we did not have any significant business benefit by putting that in. So these microservices will work with Istio. There will be some Sunbird branch where the Istio code can also be figured out in Sunbird DevOps repository. They will work with Istio, but unless you have a business benefit, there's no point in consuming additional tens.
Say, if I'm using a Istio service mesh or any other service mesh for that matter, and I have one Kubernetes cluster and I have another Kubernetes cluster set up, say some sort of a Kubernetes, I can just mirror the production traffic to that cluster, and I can in real time look into what is happening and go into that system.
Correct.
So yeah, so that's what my question was.
Yeah, so in one of our environments, we had a real-time need to mirror one of the API calls. So we actually did that. Nginx supports mirroring.
Okay.
So, I mean, there are ways to work around that without really putting something as complex as an Istio.
And Istio would essentially will also connect. So Istio also will, you said that OPA you have created. Right?
Yeah, so it also uses sidecars only.
Yeah, so Istio is basically on invoice, so it will also connect with OPA
Yeah.
seamlessly, right?
Yes, yes.
So currently, how that OPA architecture is being?
It's running Envoy as a sidecar,
Okay.
and the OPA agent as a sidecar, and your actual service. So it's using the sidecar pattern only.
One more question about the tracker ID that you said.
Trace ID.
Trace ID.
Yeah.
So we are you are adding it for all the requests. So is it on by default or is it configurable or how?
It is configurable in Nginx, and it is not always added. If the client sends a trace ID, we don't add. So if, let's say, the portal team decides that they want to use a particular trace ID for one of their calls, and they deploy, Nginx will not override. So it actually looks at X trace ID present. If it's not present, it will put it.
And I can track it across all the services, all the service requests.
Yes, with a caveat. If there is a developer who has not forwarded that header to the next hop, then there will be but that's easily fixable.
And that's where this Jaeger will come in.
Yeah, that's where eager-like tools become valuable, but then scaling that is another activity. Yeah,
In the scale
yeah, yeah,
system like this.
yeah.
Eager also having specific format, the log format. We evaluated Eager also, like before we go with Trace ID.
Yeah.
We evaluated Eager. But even if you want to Eager also to work properly, you have to log even in the proper format what Eager is
Yeah, so there are auto tracing APIs also. See,
the APIs can be tracked, but if you want to the call stack, all the services
Yeah,
should.
and I'll add to that, when you use an actor model kind of paradigm, right, or a reactive paradigm, it's slightly tricky. So
Here the gray logs play a very key role. Okay, like when you have a trace ID, you search the trace ID, the gray log, to see all the logs by all the services. Okay, where the failure happened. Even the error cases also, services are logging with the trace ID. Okay, error event will be logged with the trace ID.
So even the middlewares, this knowledge middleware and the other Node.js services, they are also using this trace ID header. Right?
Yes.
For propagate, no?
yes, yes.
You want to just show the slides that you skipped and then maybe see if any questions are there.
Yeah.
Can you just tell me like the use of the gray log? I don't understand.
Graylog is a log aggregation tool. Like Elasticsearch is there, right?
Right.
It's a layer on top of Elasticsearch.
Okay.
So all the data flows into Graylog, and Graylog stores it in Elasticsearch.
Okay. So from where data is flow into the
Fluent bit. So if you see the stack, right? So Fluent bit is pushing all the logs into Graylog. It's a push mechanism.
Okay.
It's not a pull. Prometheus is a pull.
Okay.
Fluent bit is a push to the Graylog.
Like ports data? Which
Okay. So on Kubernetes, Fluent bit will read all the logs that you write to standard out, which is your console logging, and it will ingest that into Greylog.
Console log is writing
Yeah,
the Greylog,
yeah,
and the
yeah.
Greylog write that log into the
Elasticsearch. So no, you don't have to think about Greylog and Elasticsearch being there, because if you are having Greylog, Elasticsearch is just the underlying. You can use it like assume that it's like the database. You are still watching the dashboards on Greylog.
I'm watching the logs on the Greylog.
Yes,
the
yes,
dashboard.
yes.
Okay. The API logs and everything.
Yeah,
related to
yeah,
Greylog.
yeah,
Okay.
yeah. So at a minimum, Grafana viewer access, not admin access, and Greylog access for every developer in the team. That will empower the team. That's a minimum.
So basically, the Greylog is used for the API console logs. I can say that.
All logs in the system.
All logs in the system.
Yes.
And the Prometheus is just for the
Monitoring.
Monitoring, just system monitoring.
Not just infra, even some bit of application monitoring as well.
So over the Prometheus, we use the Grafana to just
Yes.
visualize the things.
Yes, yes.
Which is pulled by the
Prometheus, correct,
basically.
correct.
Okay. And the Greylog store the system and the API console, everything.
Yes. So that is done by the file beat. There's another daemon.
Why should I use the Prometheus if I'm able to see everything in the Greylog?
Greylog is only logs, right? You will not see response time in the logs, right?
Okay.
So,
Just the console log basically.
console logs.
Application logs.
Your application logs and all will come into Greylog,
Okay.
right? But if you want to know how much CPU your, let's say, Lern service is using, sysout and syserror will come into Greylog. And everything else, the monitoring aspects, you want to know.
Metrics data basically.
Metrics.
Yeah.
Okay.
Your heap memory usage, your stack usage, your open file handles in JVM.
Right.
Yeah.
All that will go to the
which is a UI.
Prometheus.
Huh. QR code belongs to that company. It's certified. It's a MacBook. It has this username, password, all that kind of data you can tie it down to. So that capability is what Madhu was referring to is Sunbird RC.
So maybe I'll just add on to that. We're talking specifically about registry. Today we're looking at as one sequence of all hierarchical data. Everything is in master data. But I think when we're looking even at Diksha for that matter, at some point in time when you probably need to capture school data or student data, you should not look at it and having it one place. Every state has their own data. Why would you replicate that? Then the source of truth will have a short-lived life. So the concept of registry to see is how you can actually have this entire federated thing and still leverage on a registry. Why would you want to go, if CBSE already has a list of school data, why would you want to rebuild it? Or if a state has already got a list of all the state schools or students, why would you want to rebuild it? How do you leverage on that? Making sure that is always a source of truth, being able to leverage it. So the entire concept of registry is coming from there.
When I think in master data, I didn't set a single place.
Okay.
And I said any kind of a concept of a master data, actually like it could be federated or it could be distributed.
Yeah.
But then it becomes like any enterprise business or school or education or government or civic or whatever. So the master data or pretty.
Yeah.
Because based on that only we do a transaction.
Thank you.
Right? Or everything we refer to.
So at least in the good morning everybody.
Okay.
We don't capture any PI information, nothing at all.
Yeah.
So that's the biggest advantage from when people talk about security and all that. There's no PI captured itself, so there's no concept of that itself. So other areas may be Neo4j in terms of content or
Yeah.
in terms of other places where we actually have the main master
That is okay. Content will be changing.
data. That's about it.
Yeah.
All about.
Okay.
Yeah. Cool. So
Any slides that anybody has any questions? I think. Yeah.
Yeah.
So suppose I am running a content service on a 3 instance.
Hmm.
Okay, so I want to check.
it's out of battery. Dead. Yeah.
So content service running on a 3 instance. So I want to check like how many instances are running of a content service. How can I check that? In the Greylog I'll be able to check.
No.
That. Okay. So
You will need access to kubectl on that.
kubectl, okay.
So okay, no wait. That is if you are in the DevOps team.
Okay.
Otherwise, Grafana will give you that data.
No, one second. Like 3 instances are running. Okay.
Yep.
So I want to check each instance how many what request is coming. Right.
Basically, what he wants to understand is, what he wants to know is, I made a request to content service. Right. There are multiple instances of that content service running.
Correct.
Multiple pods running on, in a cluster.
Correct.
Now, which pod got that request?
Okay. Got it. Okay. So that is available in Greylog. So remember I spoke about the trace ID. So if you send a request and you identify what is the trace ID of the request you are, see, the first challenge is how do you pick that request, because you are getting 1,000 calls a second.
That's right.
So you have, so that's where you have to look at clients itself sending trace identifiers, right? Maybe the UUID or something hashed or something like that, right? So once you have the trace ID coming in, if you actually have Greylog, you can search by that trace ID and then you will see all the logs, and one of the constituents of the logs is which pod it was collected from.
So, just to be a little more clear, what you mentioned as clients are basically the portal and the
mobile app. Yes.
Mobile application.
Yes.
So for portal from the front end, whenever I'm making a call to any specific API, so what you're mentioning is that the portal code should be sending a trace ID along with the request that we're making.
Yes.
And that is not done by default. That needs to be implemented by the adopter. Or
We know there is some trace ID capability already there.
UIDs which will be sent to each request. There will be a UID which will be generated and sent to the backend, and it will be captured also.
Yeah.
And also you can see the response also, the same trace ID comes back.
Yeah.
Like any failure also you can see the trace ID coming back.
Correct. So the trace ID is already handled in the portal.
Portal itself. If the portal is not sending, the API manager is adding the trace ID and then Kong is actually adding the trace ID for that request. Then it's sending to all upstream.
Right. So, but how as a, let's say, how do I know that I made this request? And because again, as you mentioned,
I'll explain. So let's say that you are a user facing some challenge accessing the portal.
Right.
And I am a support personnel, I reach out to you.
Right.
When I see your network tab on Chrome, in the response, the trace ID comes back. If you
the do ID or the
no, it's a UUID. Okay, so if you give me that trace ID, I can now just do a search with that trace ID on Greylog. I'll see all the logs for those trace IDs, and along with every log, I'll see what is the pod from which I got it. So you will know it is this pod.
Okay, in the Greylog, I want
Yes.
I will be capable to check the port.
Yes.
But I need the trace ID.
Yes. If you want to look at a particular request, if your idea is how many, yeah, it will be X trace ID or something. Yeah.
MSG ID or something. Message ID.
What is it called? Header name is message ID. Yeah? Okay.
I've seen that message ID. I mean, I didn't
Okay.
know what it was, but yeah, I've seen it.
So we are planning to build some UA also for the end users where they can see what a trace is read and whether the trace is error or success. So that way, where the users can share that information just by looking into UI rather than going network tab.
Yeah.
That's still on POC stage.
Yeah.
So basically, Greylog, you like play a vital role to just check the request through
Yes.
the message ID.
Yes.
Yeah, for the dev team, I think Greylog would be one of the vital
role, right?
The tool. Both. I would say Grafana so that people actually know how their code is running in the environments, and Greylog for basic debugging.
Right,
Yeah.
debugging your backend.
Yeah.
See what happens in the server when the request
Right.
is memory problem or
Yeah.
CPU problem.
Yeah, absolutely.
Greylog will have a log error. You have to see the Grafana to see what happened to that service that way.
Okay, we are over an hour beyond the scheduled time, but considering that this has been super interactive, I think Mathew was absolutely amazing. So,
Thank you.
Any other questions before we get into the breakout sessions?
So just one clarity, I had asked earlier also. So the individual data models of the individual building blocks will be covered in their respective sessions.
Yes.
But the data products of those blocks, typically like Lern, it has data products and the other, but those will be covered in the data channel, right?
No, what?
Yeah.
Is
So on the data track would be observe building block plus all the data products, exhaust that we have from Learn and co-create would be covered in the data track, because Manoj's team will be the primary audience, right? So although currently internally
we
we
plan it in a way like if a Learn is done on the back end, then after it shouldn't clash like after that is done now I can just switch to this data product of Learn also, so that I can have a complete
Full backend understanding.
So I see. I think the way you should look at it is these recordings would be made available. So I would suggest, because now we have people coming in to take these sessions as well. So I am not sure how practical it is. Maybe I'll leave the team to think about it as a possibility.
So I think only for Learn exhaust, Mahesh and can we see if the Learn exhaust sequence can be done after Anil covers?
We'll figure out whatever best we can accommodate, we'll try and accommodate. Wherever we can accommodate, we'll try and see how we can do that.
Cool. So I think what would happen now is we have 3 tracks, as everyone is saying, and each of the tracks, here is where we'll continue with the front end track, smaller room. The room opposite to this will have the back end. No, back end. Opposite is data, and the first room is where we'll have the back end track. So the way we'll structure is the same thing. I think the agenda is already shared, right? We'll cover those topics. So we'll need to now see after this discussion. Now I don't know if we'll be able to cover how much of it will be able to cover in 5 days versus 10 days, right? So how do we handle the more questions that are coming outside of, let's say, if we're doing a code walkthrough, and if there is an application related question that comes, so should we park it as a 1 hour session at the end of the day where we talk about how this will be applied, given that we have covered these topics? Or because otherwise what would happen is in the code walkthrough, if you go into the application related questions, some of the topics might be covered, some of the topics may not be covered, right? So we'll probably need to sync up on this, because now we'll also need to keep the time in mind.
Let's focus on the original objective. Let's go through the code walkthrough, the APIs, the database, the dependencies, and then probably the last 1 hour, let's focus on questions that are asked. Let's do that.
Yeah.
Okay.
So we'll have a tea break or something.
Okay.
So I hope this was useful. I mean, this is the fundamental session for everything to actually start on. So,
So it was interesting.
Yeah. So this is the foundation. Now the breakout rooms. Yes.
You have more common sessions? Or
last day.
Last day, OCA team is running on the DevOps practices and all, right? those are all common sessions.
That last day is Monday, right?
Monday. Yeah.
Like, I have one question here. If one person has to, let's say, get into data and backend both, so then what are his options?
Unfortunately, no option.
You have to clone yourself. Because these things are connected basically. If you understand the system, these things are connected. Like backend people have to understand the data.
And all fall back on the recordings, right?
You have to just go back and record it.
One session there, like I should think like a decoupled. Like, that's the key thing what somebody always follow. Now, the contract is a key thing. If